So 3 data-centered topics. We're going to talk real quick about the diversity of all the data, the metadata, the AI data, et cetera, within the modern ecosystem, just to kind of set the stage for that. But then really most of this discussion, you'll probably hear me say the word open 100 times, I don't know. Hopefully I won't get too repetitive. But that's what this is about, right? A truly open data environment and an open analytics environment. And again, what I'm voicing is what I'm hearing and what customers are driving to, that I'm seeing. It isn't just in financial, it's in healthcare, telco. I talked to a retailer in Canada a few weeks ago, same ideas, right? In all 3 different public clouds, hybrid cloud, it's the same thing, and there's different patterns based on that we could get into. So basically, open data is a simplify, enable, AI-enabled, AI-driven analytics, and then simplify the modern ecosystem with Vantage. How these institutions, how these customers are looking at Vantage in this new world, right? And the value that hopefully Teradata can deliver for them in this modern environment. So we all know about diversity. How many folks in here have a data lake or had a data lake? Okay, 1, yeah. What's it on today? Okay. Okay, cool. All right, cool. All right. So this is just touching on some of the aspects. I added vector embeddings, RAG references, prompt engineering. I could add to that as well within this environment. Structured and unstructured data, all the data assets, right? All the data products, all the data domains, if you're meshy, right? If you're following a data mesh approach. The big thing, maybe finally, and we've been talking about this for years around the data lake and enterprise data, is the metadata management, right? And the importance of that. So all these trends are revolving around better data management, because even if you're building an open data lake, you could still get a data swamp, right? And even if you're doing a data catalog, you could still get a data cataloged data swamp, right? And so there's a lot tighter requirements, and there's balance between data integration and controlling the data versus innovation and letting everybody at the raw data files and just going to town, right? So there's this balance between that. Then certainly in financial services is a pretty important balance to strike. So this isn't a surprise, right? Actually, none of this should be a surprise. It's, again, the strength of the trend here, which is maybe surprising, right? And the amount of investment these companies are willing to put behind this, right? So the major trends on the left-hand side, so it's renewed focus on data lakes built around open data formats and open data catalogs. That's not a hard statement at all, right? I would call this data lake 3.0, right? The first data lake was, say, 10 years ago, 11 years ago, mid-2010s. David, do you want to say anything? Because I want the full treatment here, buddy. Yes. Thank you. No, that's fine. We knew this could happen, so it's all good. It's all good. I just like to pull his chain every once in a while. So there's renewed focus around data lakes built around open data formats, and I should add open data catalogs, right? And then the important thing is, the biggest thing is the open compute. And what do I mean by open compute? We'll talk more about it. But they don't want one platform to control access to their data. Does that make sense, right? So today, if you've got a Teradata enterprise data warehouse, you have to go through Teradata to get to data in our format on storage, right? If you have, pick one, Snowflake, you have to go through, right? Snowflake to get to their data. That's not what these institutions very strongly are saying. It's our data, we're going to manage it, We're going to create new data pipelines. We had the RBI session earlier, and what they are in the process of doing is creating modern data pipelines to create and do more agile data product engineering, get the data to the users faster. And then we didn't get into the discussion about open compute, and I don't know if that's how far they're going, but it's very similar, right? And so we're going to talk about on the third bullet. So you got to make this transition. You got to make this transition from a non-open data environment to an open data environment. And I'll just point this one out in the lower right-hand corner, without disrupting the business, right? People in banks, financial services, healthcare, most businesses don't like to be disrupted. You know, they don't want to say, who took my cheese, right? Or who changed the format of my cheese, right? They want it to kind of work the same, but of course get the data to them faster and be more modern. Okay, that's cool, right? But don't upset my apple cart. And that's a major thing. And it's changed the strategy of how IT organizations have gone at this transition in major ways, that disruption or trying to avoid this disruption. So, and the last one on the left-hand side, objective being really the operationalization of AI-enabled analytics. You'll hear me say AI analytics, AI-enabled analytics, trying to use less syllables. But they're all related, right? But it's the operationalization that's their focus. Today, and we'll get to the Teradata part towards the end, today, they largely operate, in many cases, so when I talk about the 4 big banks, they're the 4 or the 5 largest big banks in North America. That's what I'm drawing this discussion from, right? So you kind of know who they are. And they're all going this general direction at different phases, different strategies, but that's the direction they're going. Stated directly to me, in workshops, et cetera, right? Not just me, everybody else in the room. That's what they're moving to. So anyway, you know, so the basically strategy is all data begins and ends in that open data lake. All data. All the data that's in a 2 petabyte Teradata data warehouse has to eventually get into that open table format. That's the plan. It'll take a few years, but that's the plan. All data pipelines will produce data in open table formats. In most cases, in the customers I've been in, it's Iceberg is their choice, Apache Iceberg, because it's more open. It's open of openness, right? Yeah, is it a double O? You know, and then tools and platforms on compute must leverage open data, right? You just have to be able to consume and produce Iceberg format, Delta Lake format in an open compute, open data environment. That's their plan, right? The guy drew it on the whiteboard, and that's what we want. And there's a representation of that in the next slides. Deploy cost-effective operational AI analytics at a much higher scale, setting the stage for the true operationalization of AI. Not just, right? I mean, injecting AI into the business process, as I think we've talked a little bit about this week, right? And then, like I said earlier, without that business disruption. So those are very high-level trends, right? There's a lot more behind that, but that's generally, I think, summarizes a lot of the discussion I've had around this open data topic. And so I don't want to go into this a lot. Sue did a great job introducing this in the track yesterday around our OTF support, open table format support. It's very important. In the banks and healthcare and other companies, we're turning into a consumption engine. Help them consume those formats better. The data may not have been under management of Teradata. It may not have originally been produced by Teradata, but what they want is a high-end consumption engine to do the same thing they do today and more with AI, but at their scale, right? And they like what we do for them operationally. They want us to do it with more open table formats in their open data environment. That's going to, you know, how big in your institutions, your environments are pretty large. It will take a while to make that transition. We talked about that transition actually with a couple of them. So anyway, it's all about, you know, Delta Lake, et cetera, and object storage. I'm not going to spend a lot of time on that, just as a backgrounder. There's some other things. There's actually something called Xtable, too. That's in actually OneLake in Fabric. So there's other formats, and that's actually a cross-reference table between open table formats that sit within one lake. So it's kind of an abstraction layer. I don't think we necessarily need that in Teradata to be able to join data between Delta Lake and Iceberg or Hootie, but they're putting that there. So there's something called Xtable as well. So open data lake requirements, again, all data begins and ends with the open data lake. They want lineage to be back to that open data environment, right? Consistency, right? Try to not make so many copies of that. You know, draw it from the lake, the one lake. You're going to go fishing, you're going fishing here, right? And you're going to get largemouth bass, and that's the one you're going to get, right? In that lake. All data must transition to the open data lake, meaning what I said earlier, the petabytes or whatever, the core data sets that are on Teradata and many other systems within these institutions have to transition into the open. We're not going to re-engineer it. We're not going to re-engineer the data. It needs to be represented as an OTF, in this case, in many cases, Iceberg. All data must be registered, published via global catalogs, right? Right, you're going to register it as a data product, and we're going to track it, and we're going to track your use of it, potentially, probably, right? And we're going to see how valuable that data product is to the organization in terms of reuse and how it's being leveraged across different compute engines, different applications. And then if other storage is needed, data must have lineage with an open data lake. So if you can drive workload, this is a big part of where we're going to come in as Teradata. If we can drive workload, if you could, you would. Drive workload from relatively slow object storage. When I mean slow, right, and Sue can talk more about this, right? Slow relative to block storage, relative to memory, right, for data processing. But you have SLAs, right? And those SLAs make you have to go to other storage form. We'll talk about this at the end, right? So anyway, if other storage is needed, it must have lineage back. So if we're going to promote data to block storage in Teradata, it needs to have lineage back, or at least consistency back to the open data lake. Right? So this is the general environment, and just a nice conceptual picture. You're going to have data curation, operational data warehouse, all the different usage semantics, patterns, and there's probably 20 more, right? And through APIs, NOS data exchange, parallel connectors, push down processing, etc. You're not going to push down to open data lake, but across those compute through a connected data fabric that is in that data lake. And we say, and this is the other thing that's interesting, when we talk about a data lake, we think it's one thing. We know it's not, right? It's all that data diversity in that thing, and there's probably multiple instances of that across a multi-hybrid cloud world, right? So how's it going to work across multiple instances where there's data gravity in an open data lake, right? So that's a general picture of a picture that's been drawn a few times in these workshops I've had with these customers, right? So it's an open table format, and then there's still going to be some level of platform file systems, governed, metadata-driven, connected catalog, flattened data surface. You'll hear that term. I've heard that term in a few places. I want to flatten the data surface for our business, right? And how are you going to go about doing that? Well, I'm going to present it to them in a global catalog, and it's going to be a consistent model, not data model, but a consistent access model of how we're going to get to that data, and how am I going to authorize that, how I'm going to provide, the access rights to that, right? Needs to be flattened and made easy to do. All right, so open compute requirements. I don't think this would be, I just want to restate again what I've heard. Open compute tool and platforms must readily consume open data, all right? Tools and platforms must support open data management. That second bullet, that second thing is a huge statement. How are we as an industry going to do open data management? Acidity, right? Read-write, locks. We're a database management company. We care about those things, right? So when I'm in an open environment and someone's going to try to change, number one, you won't change a record, you will append a record, right? And they have to actually make changes to applications that might change a record, so they do not do that. They actually insert a new update, right? That data management piece, we could spend 2 hours talking about just that, but we won't. And it must enable cost-effective open AI analytics, right? It must enable what the business wants to do to turn and burn on that data to produce value from data and analytics, right? Needs to be requirement, meet these requirements without excessive data replication and latency. The data replication is back to the data swamp, right? So how much, it's all in the data lake, so it's good, but I still have 20 different customers, or 20 different copies of my customer profile in the data lake, right? They don't want that. They want to manage it. Come back to that, atomic detail system, source of truth. So want the source of truth, but it's in the open data lake environment, right? So minor little things. And so what's going to happen, and this is a representation of another picture that's been drawn a couple times, are what are the major platforms? You've got a lot of, agile sourcing, you've got ETL integration tools, you've got modern data pipelines, analytic modeling tools, et cetera, but they're not necessarily the base platform. And the base platform is really that open data lake, probably in object storage, right? Either on-prem or in the cloud or a little bit of both, or a big bit of both. You got big data platforms, right? And some of these will converge, like with VantageCloud Lake, our goal, like Databricks' goal, like everybody's goal, is to be a big data platform, that's the lake house, with advanced operational analytics. I would argue that the operational analytics is harder to do than be a big data platform at the scale that's going to be needed. That's the area that Teradata will play, right? And that's all these institutions and all the customers I've talked to are Teradata, large Teradata customers, and they intend to take this forward, take Teradata forward, VantageCloud Lake, VantageCloud, into this new environment, every single one of them. And so that's what me and David and others are here to work with customers on. So we're going to start consolidating around, because open compute could drive a lot of tech stack complexity, right? You got how many different open compute elements, right? You got one for each one, but eventually it has to coalesce around, for simplicity and other things, around some common compute stacks to access that and produce that data, right? And Gen AI, analytic processing, GPUs environments, dedicated systems for vector embeddings, or like we do within Teradata, vector embedding processing, et cetera. But that's a high level picture. So let's switch real quick. So does that make sense? Does that the overall objective and goal are pretty straightforward. Open, 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 right? And so now we're transitioning, and so warehouse, data lake, lake house, those were all non-open environments, right? For the most part, from a data perspective. They were open, you could connect to them. Teradata, you can use any ETL tool, but to get to that data, you gotta go through Teradata. That's what's changing, right? That's what's changing. But to get to that data with some effectiveness and to not have an overabundance of tech stack compute running amok, again, you're gonna just consolidate around a few key platforms, right? And so there's not just a lake house, it's, the lake house is, it's good, but what's really needed is a trusted AI ecosystem, my term for it, an open AI enabling ecosystem. I didn't say platform, I said ecosystem, right? And that's largely, again, what these institutions are building. They're gonna have that previous picture, some form of this previous picture, with 2 or 3, probably 3 or 4 major platforms that are compute to storage, right? That, operationalization, AI processing, big data, unstructured data processing, et cetera, will kind of coalesce around, right? And that remains to be seen, but that's what we've talked about, because they don't want compute run amok either, right, within these environments. So trusted AI ecosystem, right? So Teradata so I've been saying this for a while. When a business, how many's in IT here? Mostly business folks? We're actually a little bit of both nowadays anyway, right? So when you're doing something in the business, you don't necessarily care if it's a lake house, a data lake, or a warehouse. You just want to get something done, right? We in IT and the IT industry have put these terms together, right? Databricks coined the lake house because it's a combination of the data lake and the warehouse, they think. I would argue they're going to struggle with some operational warehouse things, but that's just me saying that. right? But I've seen that struggle on the part of Databricks. So VantageCloud eliminates the need to implement these 3 distinct design patterns as multiple platforms, right? So on foundational platform, I believe we can be a foundational platform in the AI ecosystem. And I don't just believe that. That is the plans that these institutions have, because they operate today on-premise largely for risk and finance, for claim processing, for major workloads operationally on us and a few other platforms, right? They don't want to disrupt the business by completely going to something else. You know, they want to inject more AI into those operational processes that we support today, but on open data and with some other key platforms like, you know, GPU clusters and other things, right? So we basically want to accelerate AI analytics time to value by drawing from consistent data sources in that open data lake. Open data consumption for all users, operational efficiency at true enterprise scale, low cost data, but all around open data. And this, look at Sue from our engineering organization, right? It is so critical that we have performant access at enterprise scale to open data formats, right? And if we don't, you're not gonna be able to drive the workload response time and throughput that you do today with an open data format. So how do you get the best of both worlds? That's what we're trying to drive to, right? So I'll talk a little bit more about that. So what we're gonna switch to is, for us, in our positioning, pretty straight out, and this is, again, you know, drawing Vantage in their architectures, right? As that operational AI analytic foundation, one of them, right? Around VantageCloud Lake, that's gonna natively access open table formats, right? And drive performance and throughput through those open table formats, right? So I'm looking at Sube over there, it's like, no big deal, no challenge there, right? Because we don't control the format, right? But we gotta make it work at those enterprise scales. It's a big deal, it's a big deal. So just a couple more slides to kind of sum this up. So how Teradata meets, right? So drive performance through native support of open table formats. We'll talk in the next slide a little bit more about that. Ability to match storage to performance SLAs, right? We don't want everything in block storage, right? Well, maybe we do, if the SLA requires it. But remember, the data's got to come from the open data lake. Remember the requirements that we talked about earlier. How do we, working with, you know, you, drive SLAs against data that's in relatively slow object storage? Object storage has good throughput, meaning you can pump a lot of data through it, right? It's got good volumetrics, right? But in terms of a single I/O rate, it's relatively slow compared to block storage or memory, right? But yet we need it to drive the SLAs. So next slide, we'll talk a little bit more about that. Apply different types of the compute to adapt to application requirements. So VantageCloud Lake has multiple different cluster types. We have the primary cluster, we have a database compute cluster, we have analytic compute clusters, we're gonna have GPU clusters, already have them, right? So you're gonna have different cluster types, open cluster types, sitting on a common data fabric, orchestrated within that platform. That's the vision of Cloud Lake, right? In an open compute. And we're gonna tie our platform directly into that open compute environment, right? You have Python code running in some analytic cluster, cool, right? And send that data across the fabric and orchestrate a pipeline that includes multiple clusters. It's a distributed processing system, inherently, right? Leverage distributed query workload processing and bring the processing to the data, right? What happens in a lot of analytic environments, and correct me if I'm wrong, it's what I call run and dump. Run an analytic, dump a file. Somebody else picks up that file you just dumped and puts it in their engine. They do their thing and dump another file, right? So it's a bunch of run and dumps, and maybe that'll be an all OTF, right? But with Vantage and other platforms as well, you can have a consistent orchestrated pipeline where I'm dumping data actually in Spool or in NOS Spool or in other things that we're building in VantageCloud Lake. So I have a seamless pipeline that doesn't have a bunch of run and dump of files. It's just an I/O pattern through the data pipeline, right? And it can be orchestrated and optimized by our world-class optimization engine. Right? Deliver high levels of throughput and performance on an efficient enterprise platform, again, built on our open table formats. Right? We have to. We have to. Right? And because that's going to be it's the requirement, absolute requirement. I remember the first meeting I had at one of these banks, and may have been the third meeting, and they were very clear. And they want us to help enable that future. They want us to help enable that future, right? So I'll take that challenge, right? Because I think it's where this industry is going over the next 3 or 4 or 5 years, right? Around open data. There's going to be a lot of compromises in the industry of how we get OTFs to work, right? And somebody asked me the other day, I was in a telco in Canada. They said, is this a fad? They said, is it a fad? Is it like, And I'm going, no, this is not a fad. We have major telcos, consumer product organizations that are betting their whole data architecture future around open table formats. So it's not a fad at all. And we have to support that in the industry. Right? So, you've seen this picture before, I'm not going to go through it again, but those are all the different open computes, and we can tie different type of compute types into that data fabric that inherently uses different types of storage and different type of file formats on the bottom in this layer right here, right? The one we use the most, right, in today's world is the block file system, object file system, our proprietary object file system, open table formats, open file formats. We can do NOS read and write on Parquet today. Been able to do that for a while through an object store, what we call NOS read and write. But what we have to do is really, for these institutions, they don't want a copy of the data in the open table format and our object file system. They want it in the open table format. So the native support that we have to drive to is really important. But what we're doing, is we're basically doing open heart surgery to the core parallelism engines within Teradata to natively support OTFs and mobile OTFs, right? You could actually read, potentially, I don't want to get too ahead of my skis, but you could read a Delta Lake and an Iceberg file. It goes into the AMP level, and you could do a join on it, right? Potentially, because we've kind of, I don't want to use the word normalized, but we've kind of normalized that data across our AMPs, right, on the system, and now I can join between Delta and our format and data in EBS and maybe a Parquet file that's still sitting out there, right? I don't want to take that too far, but that's what we're working towards, right? So that is really important, and that, but it's still relatively, the speed, the I/O rate of open table formats in an object store are still relatively slow for certain SLA workloads, right? So this was one of our common slides within Teradata, right? And I'm not going to go through this. It's basically kind of laying it out. This is actually a really good slide to kind of, lay out and align, right? But what's going to need to happen here is slow storage and OTF aligned to an SLA is there could be covering views. So I could have data in my open table format that sits in the open table format in the object store, so it's consistent to remember that requires back to the data in the open table format. But then I can put a covering view on it and put that in EBS, in block storage, right? We have views. They've worked really well for a long time, right? And again, I don't want to say this is here now, but that's exactly, Zub, is that kind of where we're going? Yeah, within engineering, right? We've got some work to do. But we already have indexes that will actually cover, and we can do, and I have many customers that have used join indexes, aggregate join indexes for tactical query performance, right? We kind of pin that data, if you will, in an AJI, and it works really well because it's still one IO to that data element that I'm trying to feed back out to the customer. We can do the same thing and still meet the lineage back to the open table format in the object store, right? So there's going to be different ways that we're going to go about doing that and supporting that. So I can still get my overall goal around the open table format, but I can drive the operational SLAs that I really need, right? and do it, using the power of the platform. And there'll be other cross things around here too. We might actually use our own object file system for certain things, promote data temporarily into the object file system, right? As a cache or spool or something, right, within that environment. But again, follow the rules that the data has to reside and be pulled from consistently the OTF, right? So basically what we're doing, back to all those requirements earlier, is I have open data as like the king on top, king or queen on top, right? And I got to drive performance SLAs on the left-hand side, so I'm going to do write-fit storage and memory to that. And efficient scaling utilization, adaptable compute on a common data fabric. And then optimize workload throughput and price performance, what we got to drive through, leveraging our latest platform called VantageCloud Lake. So that's really what these getting back to the beginning, really what these institutions are doing, are giving us a set of requirements, right, around open data and what they want, how they want their data environment to work in the future years, and we have to meet those requirements as Teradata. All right, so with that, that's my last slide. Did that make sense? Right? I didn't count how many times I said open, but it was probably close to 100, right? I didn't mean to do that, but it is what it is, right? So anyway, we want to do some questions. Do you have any questions about this? It's easy. It's all open. Go forth and conquer. Okay.
Teradata into the open lake, and this is going to be a journey over time for many of these organizations we're talking to. Do many of them have a target for, like, in 2 years' time they want 30 or 40% of their data in the lake versus in their proprietary file systems?
2 to 3 years, yeah, and all of it, right? So we actually went through with a couple banks already the different design patterns of how we start transitioning to the open lake, right? Of data on Teradata and other places, right? They've got their modern data pipelines, and they're going to start producing Iceberg instead of some proprietary load ready for Teradata or something else, right? And so, yes, and it's all, I've got 6 different patterns. I can't share because we worked through it with the customer, right? But we're starting to build a plan of how we do that transition, right? Without impacting the business. Remember that rule? It's kind of important. Okay, we had another question.
Another question.
I was wondering, we're talking about more the technical metadata, but you also have to declare it, like business definitions.
Business glossary.
Your business glossary, exactly. A practical question from my side is, how is the interaction done with, for example, Colibra or other data management or open data management tooling? How is it incorporated?
That's a really good question, because it hasn't been easy. Exactly, right? For like 25 years, right? Since catalogs came out, right? But one of my, why can't it be easier? Data's so hard, why does metadata have to be even harder, right? So back to your question. We are working at the common API level. They have to expose the APIs to do that. We've actually worked, and Calibra's actually worked to interface back with us. And so it's interesting, though, if a customer is more fully in the cloud, they're going to use, like they're at AWS, they're going to use Glue Catalog, right? But when you find a hybrid cloud customer, like a couple of these banks are, they're going to go at Calibra, right? Is the most common one, right? And so it's interesting, your question is, how am I going to do metadata exchange? How am I going to get at that business glossary, right? AI is going to play a role. I don't want to just say AI, right? But AI is going to play a role in that, right? In terms of potentially vector embeddings within that environment, right? The other thing the reason it's so interesting is the biggest challenge with data catalogs and metadata management is the data exchange. Everybody has a scanner that looks in and pulls the data out. But what if I can share it out as an OTF, right? That's what needs to happen. So not only does the data have to be stored in OTF, the metadata should be in an OTF representation as well, right? And then Calibra, that's When I'm in on-prem, that's my data cap, but oh, I'm hybrid cloud, so I'm gonna use Glue over there, or maybe I'll use Calibra over there too, right? And now I have this OTF, so I can just kind of inherently, there's no metadata definition standards, but at least I don't have to reach into the system, do a scanner, they should just publish it, right? So that's a deeper conversation, but there's hope around metadata exchange because it should be more open, right? No, and I don't think there will be, right? That's why we're open, right? We don't have our own, right? We'll use Unity, because we're agnostic, because we're gonna need to be, right? Because we want you to keep your metadata and data, that's like the most important data. And then I wanna actually use AI on top of metadata to see, and we're actually working on this, right? We have our own FSDM, just a little side comment. We have our own financial services data model and many other industry data models that are very rich in business glossary terms, right? In definitions. That's why you use them as a reference model. We're putting that through AI, so you can actually kind of converse with the model without having to use Erlang, right? It's kind of cool. It's actually kind of cool. Yeah. We can do that too.
We can make that happen. We can come to Amsterdam
it's
again.
not an interview, it's a working discussion. I did this with the retail in Canada 2 weeks ago. I didn't use any of these slides. I just went and did it all whiteboard, and then he got up and, before, I'm not the best artist in the world. Yeah, that's the way we get things done. And that's how we did it originally at one of the major banks is I had the slides, but we just went right to the whiteboard. Right. Yes?
Any other questions?
Hey, Bob, you talked about this concept of flattening the data surface.
To the user perspective.
To the user, okay.
Yeah, from the user perspective.
Can you just help me draw a line from open table format to how that gets enabled? What's the true concept of that?
Well, there's nothing magic about open table format to flatten the data surface other than the data's in a common format, right? That's what I was talking about earlier. You could still create a data, cesspool, whatever term you want to use, right? An unmanaged data lake with OTFs, right? What customers want to, I'm just repeating a term that one of the CDOs said, I want to flatten the data surface to my users. I want a consistent interface through that metadata presented consistently through a click catalog, and I want them to be able to see all the data resources that they're entitled to. Entitlement is a huge deal in this, right? And I just want to flatten that for them. I want one pane of glass, right? And they should not care what system they're accessing, right? They shouldn't care. Compute should form and to process on what they're trying to do, right?
So I've had that, excuse me, had that term come up in customer meetings as well. And one of the points that they brought up before is that today, you use different platforms for different types of data, and different departments use different ones of those platforms. And right now your choice is either I have to duplicate my data and have complexity and keeping them in sync, or I have to have my end users be comfortable on Teradata and Databricks and some third platform, because that's where all the data lives. Whereas in a world where it's one data layer within an OTF, whatever tool a specific line of business is most comfortable with, they only interact with that one tool to have access to the single source of truth, one data layer below it. So I think that's where it's for each specific user, the data surface is flattened. Different users may access through different tools, but that user doesn't have to learn multiple technologies just to get all the data.
That's the compute that's bound to, this isn't here today, right? But the compute that's bound to that user request needs to be flexible based on what that user's trying to do, right? And they shouldn't care. They'll say, oh, I'm accessing data in the data lake, check the box, cool, right? But they shouldn't care, right? That's what he means. He wants to simplify. He wants to get rid of our systems being exposed through their data, right?
Hi, where do the data clean rooms fit in this picture? Like usually we have this open data lake being shared within an organization, but what if I have to share the data with a third party? Like,
Well, actually open table formats you still need a data marketplace type of functionality, right? So you can control entitlements to that on the other side, right? And exchange and monetize that data if you're going to try to monetize it, right? I mean, what's the charge for that data product, literally, right? So you still need some of that infrastructure, but our view of that is that the data providers, the cloud data providers will provide those data marketplaces, or there'll be some on-prem as well that we can leverage. I mean, I've had that conversation with Calibra from a data sharing perspective as one example, right? So yeah, I mean, the sharing is inherently easier because now it's in one format. You don't have to go through a platform, Snowflake, right, to get at your data, right? It's just open. But it's that metadata, it's that financial metadata and the controls around it, the pub and sub metaphors, right, that need to be available within that environment to receive the updates that you've subscribed to, right? But you don't necessarily need a repository to do that. The repository is different regions of your object store that are in the shared region. And there will be Delta Lake shared, there will be Iceberg shared, there'll be Parquet shared, there'll be Hootie, there'll be, you know, whatever the beta and VHS formats are in the future. If you lived through that in the 1980s. I always date myself, so I'm sorry.
Okay, so I think we've got time for one last question, if anyone wants to put their hand up. Jim.
Uh-oh.
Tough one, isn't it?
You're gonna let me finish strong here, I can tell. That's good.
Yeah. So I understand when it catalogs metadata, but what about permission management at a flat surface level?
Say that was?
Managing permissions, governing permissions, and not having to go to one engine to do that.
That is the big conversation we're having right now with one of the banks that we're about ready to move them into the cloud. They have a new entitlement access layer, or whatever term, you know, with the access rights through, you know, their different levels of their security to get to put PII data in AWS, right? So that's a really interesting conversation with a multinational bank, right? That entitlement framework, that's kind of what I call it, is like the core of the conversation. It isn't just data catalog, it's the entitlements around that data catalog, which is the most important, right? Because otherwise it's just not going to happen. If they can't audit it, it ain't happening, right? That's great.
Great question to finish the session.
Yeah,
so
very good.
thank you very much, Paul.
Thank you.